Okay students, so let's start with the next exercise, exercise 3.4, the very last exercise of this chapter. So important questions we'll be solving. The first question which I have taken here is question number 8. So find the inverse of the matrix if it exists, and they have given the matrix like this. We have to find the inverse of this matrix. So the relationship what we have seen in the synopsis, students. Solution. So first let us see with respect to the numbers. Okay, so for example, if you take a number 6, if you take the inverse of this number, that would be equal to 1 by 6, correct? So now 6 and 6 will get cancelled, this will be equal to how much? 1. This is in what? Numbers. If you have to see it in matrix now, okay, so you have to take a matrix. So let us consider this matrix as A. So this is matrix A, and inverse of A is nothing but 1 by A, that is nothing but A inverse. So this 1 by 6 can also be written as what? 6 inverse, right? 6 to the power of minus 1 is nothing but 1 by 6. So A into A inverse will be equal to how much? I. So we will be using this relationship now. So we'll use this again. So this is in matrix, this is in numbers. So here we'll write A dot A inverse equals I. Send this inverse to the right hand side. What will happen? A will be equal to I into A. Correct. So now we'll substitute for A here first, and we'll also substitute for I. What is A? 4, 5, 3, 4. 4, 5, 3, 4. And what is I here? I is 1, 0, 0, 1, identity matrix. And this A as it is. Now students, what is the heading? See the heading again. Find the inverse, right? To find out the inverse, what you have to do here, as I have told you in the synopsis, you have to get this identity matrix on this side. But how do we get that? By using the row transformations or elementary row operations. Row or column, anything is fine, but I would prefer row. Okay, row is better, students. Also stick on to the row. So what we have to do here, we have to get this matrix here, right? So the very first thing, see here we have 4, but here we have 1. We have to make this as 1 now. How do we make it as 1? Right here, R1 is equal to, 4 is there, 3 is there, right? R1 minus R2, correct? 4 minus 3 will become equal to how much? 1. So by applying this operation, what do we get? 4 minus 3, 1. 5 minus 4, 1. 3 as it is, 4 as it is, because we are not doing anything to R2 here, which is equal to, same thing, R1 minus R2. 1 minus 0 is 1 only. 0 minus 1 is minus 1. The second row as it is, 0, 1, and here we will be writing A. Understood? So now we got 1 here. We are going to make this as 0 next. So see, 1 we got. We'll make this as 0. How do we make this as 0 again? Elementary row operations again. Okay. So we'll draw a line here. So the next operation what we'll be using is R2 equals, R2 is equal to R2 minus 3 times of R1. Correct? What is R2? 3. Minus 3 times of what is R1? 1. So 3 minus 3 will become equal to 0. Right? So here you write 1, 0. 1 as it is. So R1, R2. So that is 4. Minus 3 times of 1. 4 minus 3, that will also be equal to 1. Which is equal to, R1 we will write as it is, 1 minus 1. R2 apply the operation, R2 minus 3 times of R1, that will become equal to minus 3. And R2 minus 3 times of R1. So 1 minus 3 of minus 1, that will become plus 3. 1 plus 3 is equal to 4 into A. Understanding? Okay. So now you see here, compare the identity matrix with this. These principal diagonal elements we got 1, 1. Here also we got 0. The last thing what we have to make is this to be as 0. If this becomes 0, we'll be getting our inverse. Make the 0, student. This is in R1, right? Again operate R1 equals R1 minus R2, correct? 1 minus 1, this will become how much? 0. So right here, 1, 0, 0, 1, which is equal to 1. So R1. R1 minus R2. So that will become 1 minus of minus 3. So that will become 1 plus 3, that is equal to 4. Same thing, minus 1, minus 4, minus 5, R2 as it is, minus 3 and 4. This will be our A. Now rewrite the students. This can be written as what? I equals 4 minus 5 minus 3 and 4 into A. Now send this A on that side again. What will happen? A inverse of I is equal to 4 minus 5 minus 3, 4. So what is A inverse into I? So this is very similar to 1 by 6 into 1. How much? 1 by 6 only, right? Same thing. A inverse into I will be equal to A inverse, which is equal to 4 minus 5 minus 3 and 4. So this will be the right answer. So this is our A inverse. How do we find it out? By using this. Okay, this is very similar to what? This here. So this is our final solution for the 8th question, students. Okay, moving on to the next one. Same thing only, find the inverse of the matrix if it exists. Here the order was 2 cross 2, right? Same thing we have to do here, but here the order is 3 cross 3. We have to start with what? A dot A inverse is equal to I. So solution. A dot A inverse equals I. A inverse will send it that side. A equals IA. Correct? Substitute the terms now only for A and I. What is A, students? 2 minus 3, 3. 2, 2, 3. 3 minus 2 and 2. Which is equal to I, identity matrix 1, 1, 1. And A as it is, we'll write. Now what we have to do here, students, we have to get this identity matrix on this side by using elementary row operations. So as I said in the synopsis, what you have to do for, or what is the steps you have to follow? 5 steps I had told in the synopsis. Make the very first element, that is A11, you make it as 1 first. Can we make it as 1 now? R1 minus R3 it will become 0. R1 minus R3 it will become minus 1. Okay. So what we'll do here is, here we'll write a row operation. R1 equals R1 divided by 2. So R1 divided by 2 means 2 by 2 will become 1, right? So once this becomes 1, make these both elements 0 with respect to this. Okay. So this is what I have told you in the synopsis. Same thing will be following in problems as well. So R1 is equal to R1 by 2. What will happen here, students? R1 by 2 is 1. This is becoming minus 3 by 2. This is becoming 3 by 2. R2 and R3 are same. 2, 2, 3. 3 minus 2, 2. Which is equal to, same operation is applicable to the right hand side as well. So this will become 1 by 2, 0, 0, 0, 1, 0, 0, 0, 1. A. This has become 1. Now with respect to this element, that is A11, with respect to A11, make A21 and A31 as 0. So how do we make that as 0 now? See this. Here we'll write. So this is in second row and third row, right? R2 equals R2 minus 2 times of R1. R3 equals R3 minus 3 times of R1. Do it together, students. So once you do this together, what is happening? This and this is becoming 0. Correct. So this is the procedure you have to follow. Always make the first element, that is A11 as 1. Okay, either by like this, make it 1 like this, or make it 1 like this. Once this becomes 1 with respect to this, make the other 2 elements below that as 0. So I've written the row operation here. We'll just operate them now. What will happen? So 2 minus 2 is 0, 3 minus 3 is 0. So here, students, R2 and R3 are getting modified. R1 is as it is. So write the first row element as it is. So that is 1 minus 3 by 2, 3 by 2, which is equal to 1 by 2, 0, 0, A. R2 minus 2R1, 0. R3 minus 3R1, 0. Finished. Now do this. R2 minus 2R1, 2 minus 2 times of minus 3 by 2. Minus into minus will become plus, 2 and 2 will get cancelled. 2 plus 3 is equal to 5. Write 5. Next, R2, 3 minus 2 times of 3 by 2. So 2 and 2 will get cancelled. 3 minus 3 will again become 0. Next, R3 equals R3 minus 3R1. R3 is minus 2. Minus 3 times of minus of 3 by 2. So this will become minus 2 plus 9 by 2. So here we'll do, students. Minus 2 plus 9 by 2, which is equal to minus 4 plus 9 by 2, which is equal to 5 by 2. Here we'll write 5 by 2. Check that again. Minus 2 minus 3 into minus 3 by 2. Minus into minus will become plus. Yeah. So plus 9 by 2 operation we have done. So 5 by 2 is the answer here. Next, R3 minus 3R1 again. What is R3? 2 minus 3 times of 3 by 2. 2 minus 9 by 2. 2 minus 9 by 2. This will give us 4 minus 9 by 2, which is equal to minus 5 by 2. Here we'll write minus 5 by 2. Understanding? So R1 we have written as it is because we did not include R1 here. So that is not modified. R2 and R3 we modified. So this is the working here. Okay, so this you can do at the right hand side of your worksheet in your papers. Same thing applicable here as well now. R2 minus 2R1, 0 minus 2 times of 1 by 2. So that will become minus 1. 1, so this will become 1 only. 0 and 0, so this will be 0 as well. R3 minus 3 times of R1, 0 minus 3 by 2. So it will become minus 3 by 2. 0 minus 3 of R1 is 0 only. And 1 minus 3 times of 0 will be 1 itself. So now you see the students, this row, this column are matching. What you have to do next is, here you made A11 as 1, right? In the next step, you have to make this as 1. Okay, so this R2 as you have to make it as 1. Once it becomes 1, with respect to this, you can make these both elements 0. Okay, how do we make this as 1 now? It is in R2, second row. So we'll write R2 equals R2 by 5. R2 by 5, what will happen? 0 by 5 is 0, 5 by 5 is 1, 0 by 5 is again 0. Understanding? So we'll apply this operation now. On this side we'll start. R2 by 5. So here we'll write R1 and R3 are same. So 1 minus 3 by 2, 3 by 2 is equal to 1 by 2, 0, 0, A. R1, what is R3? 0, 5 by 2, minus 5 by 2, minus 3 by 2, 0 and 1. So this is remaining 0 by 5 is 0 only, 5 by 5 is 1, 0 by 5 is 0 only. So minus 1 by 5, correct? This will become 1 by 5 and this will become again 0. Now see the students, which element is this? A22. With respect to A22, make A12 and A32 as 0. Understanding? So we'll write that operation now. With respect to A22, we have to make A12 and A32 as 0. So we'll write R1 equals. So you have to think, students, with respect to this, how can I make this 0? So take R1 as it is. So now you have what? Minus 3 by 2. So minus 3 by 2 plus 2 by 3 R2. Is that correct? Okay, so see the working here, I'll show you. What is R1? Minus 3 by 2. Minus 3 by 2 plus 2 by 3 into, what is R2, students? R2 is how much? R2 is 1. So 1. So I thought it's okay. So this is not getting 0, right? It's not becoming 0. So what we'll do here, we'll just erase this. The operation is wrong. So this is how you have to trial and error in the examination as well. So we are not getting 0, right? So erase this here again. So it is not 2 by 3, it is 3 by 2 R2, that's all. Plus 3 by 2 R2. 3 by 2 into 1, that is plus 3 by 2. And here what do we have? Minus 3 by 2. So minus 3 by 2 plus 3 by 2 will give us 0. So this is becoming 0. Similarly for R3, R3 equals R3, so this is positive, right? Minus 5 by 2 R1. So plus 5 by 2 minus 5 by 2 into what is R1? 1. So even this is becoming 0. So in the next, the matrix will something look like this. Okay, R1, R3 are getting changed, but R2 is same. So write R2 first. 0, 1, 0, which is equal to R2 again same thing. Minus 1 by 5, 1 by 5, 0 into A. Change the R1 now. R1 plus 3 by 2 R2. R1 plus 3 by 2 R2 is same. R3 minus 5 by 2 R1. R3. So this is not R1 students, it's actually R2 here. Okay, small mistake. Okay, so R3 is 0, minus 5 by 2 of R2 is 0 again. So these both will become 0, we have checked that. From checking only we have written this row operation. And the last thing, R1, 3 by 2 plus 3 by 2 of 0. So that will become 3 by 2 only. And here R3 is minus 5 by 2, minus 5 by 2 of R2. So that will become minus 5 by 2 itself, as it is. This side also same operation, same these both operations are applicable on the right hand side as well. R1 plus 3 by 2 R2, what is R1 here? So here we'll write R1 is 1 by 2 plus 3 by 2 of R2 is minus 1 by 5. So which is equal to 1 by 2 minus 3 by 10, which is equal to 10, 5 minus 3, which is equal to 2 by 5. So here we'll write how much? 2 by 5. Same thing next. R1 is 0 plus 3 by 2 of R2. So that will become 3 by 6, 3 by 10. Here we'll write 3 by 10. Next, R1 0 plus 3 by 2 of, this is becoming 0 itself, no changes. Next R3. R3 is how much? Minus 3 by 2, minus 5 by 2 into, okay, so this again we have to work out. Here we'll work out students. Okay, in this box. See this one. R3 is minus 3 by 2. Minus 3 by 2, minus 5 by 2 of R2. R2 is minus 1 by 5. So this will be equal to how much? Minus 3 by 2 plus minus into minus is plus 5 by 5 2 is 10. So this is becoming 1 and 2. So minus 3 by 2 plus 1 by 2, which is equal to by 2 minus 3 plus 1 is minus 2. So this will become minus 1. Here we'll be getting minus 1. Next, R3 minus 5 by 2 of R2. R3 is 0. Minus 5 by 2 of R2 is 1 by 5. So that will become 5 by 10. That is nothing but minus 1 by 2. Correct? Minus 5 by 2 into 1 by 5. Minus 1 by 2 is correct. Next, R3 is 1. Minus 5 by 2 of 0. So that this whole term is becoming 0 there. So here it will be only 1. So see the students. This and this are matching. This and this are matching. Now you have to make this as 1. With respect to this, you have to make this 0. So then you will be getting your final answer. Okay. So now we'll make this as 1 students. That is A33 element will make it as 1. How do we make that as 1 now? So this is in R3, right? R3 equals minus 2 by 5 into R3. Correct? Minus 2 by 5 into R3, 2 cancel, 5 cancel, minus into minus is plus 1. So this will become 1 then. So R1 and R2 are unchanged, write them as it is first. 1, 0, 3 by 2, 0, 1, 0, 0, 0, So this will become 1, which is equal to R1 and R2, same, 2 by 5, 3 by 10, 0, minus 1 by 5, 1 by 5, 0. So R3 is minus 2 by 5 into R3. So that will become plus 2 by 5. Minus 2 by 5 into R3. So minus into minus will become plus, 2 and 2 will get cancelled, 1 by 5. Minus 2 by 5 into R3, it will become minus 2 by 5 into A. Students, we already almost matched, right? See this and see this. You have to make only this as 0. If this becomes 0, you will be getting your inverse. So for that, what is the operation we will be doing? You have to make this 0 with respect to this one. Okay. So we will start. This is in R1, right? So R1 is equal to R1 minus 3 by 2 of R3. 3 by 2 of what is R3, students? 1. Plus 3 by 2 minus 3 by 2, this will become how much? 0. Now see, we are only doing R1, right? Which means R2 and R3 are untouched. So finish writing them first. Then you can start writing R1. Okay. So below that we'll write again. R2 and R3 will write 0, 1, 0, 0, 0, 1, which is equal to minus 1 by 5, 1 by 5, 0, 2 by 5, 1 by 5, minus 2 by 5. Okay. So now R1 minus 3 by 2 of R3. 1 minus, so this is becoming 1, this is becoming 0, this is again becoming 0, correct? 3 by 2 minus 3 by 2 of R3 is 1. Same thing here, 2 by 5. Okay, so here we have to work out again. So for working out, we will take this space. Okay, this space we'll take here. R1 minus 3 by 2 of R2. R1 is how much? 2 by 5. 2 by 5 minus 3 by 2 of R3. Sorry, R1 is 2 by 5 minus 3 by 2 of R3 is how much, students? 2 by 5 again, minus 3 by 2 of 2 by 5, which is equal to 2 by 5 minus 6 by 10. This is again becoming 2 3s are, 2 5s are, which is equal to 2 by 5 minus 3 by 5, which is equal to minus 1 by 5. So here what you have to write, students? In the place of R1 you have to write minus 1 by 5. Understanding? Next, same thing, R1 3 by 10, 3 by 10 minus 3 by 2 of R3. What is R3 there? 1 by 5, correct? See this R3? 1 by 5 minus 3 by 2 of R5. So here it will become 3 by 10 minus 3 by 10, this is becoming 0. Next, same thing again, R1 0 minus 3 by 2 of 2 by 5. 2 and 2 will get cancelled, minus into minus is plus. So this will become plus 3 by 5 here. 3 by 5 into A. This is what, students? I. This is A. Send this A on this side. I into A inverse is A inverse only. So therefore you can finally write A inverse equals minus 1 by 5, 0, 3 by 5, minus 1 by 5, 1 by 5, 0, 2 by 5, 1 by 5, minus 2 by 5. This will be your A inverse. Okay, so I'll just summarize this whole thing once. Okay, either 2 cross 2 or 3 cross 3, what you have to do is first make this element as 1. Once you make this as 1 with respect to this, make them both 0. Next, make this as 1 with respect to this, make them both 0. Next, make this as 1 with respect to this, make them both 0. During this process, whatever elementary row operations you are using to make this as 1 and make them as 0, the same operations must also be applied on this side. So at the end, when you obtain an identity matrix on the left hand side, whatever matrix that has been derived from all these elementary row operations, this will be called as the A inverse. I hope you understood this, students. Okay, make a note of this Any doubts, please do comment in the comment section. We'll move on to the next problem. So before we move on to the next problem, so in this problem, if you observe, I have put rough columns on both the sides. The reason I'll tell you, in the previous problem, the A inverse whatever we got, the very first element we have got the answer as minus 1 by 5. See, there is some calculation mistake. Okay, basic simple calculation, addition and subtraction. So it must be minus 2 by 5, just make a note. Okay, find out where is the mistake. Simple calculation. So just to avoid those kind of mistakes, what we have done this time, we have put the rough columns. So this is my suggestion to my students. So please use the rough columns, okay, or draw these rough columns in your examinations as well, especially for matrices, because there are many operations which will be carrying on. If there is a single mistake, then you might lose the marks. So by using the rough columns, I think there will be no mistakes. So this time we'll be using them, okay, and we'll be getting the right answer. So moving to the next question, number 17. Same thing, you have to find out what is the inverse of A here. We'll start with what, students? A dot A inverse equals I. This is A, 2 0 minus 1, 5 1 0 0 1 3. Okay, A inverse will send it on that side, I as it is again, 1 1 1 0 0 0 0 0 and 0 as well. A again written like this. What is your aim? You have to get this matrix on this side. So first of all, what we have to do, we have to make this as 1 and make these both as 0 with respect to this, correct? We'll make this as 1 now. How do we do that? R1 equals R1 by 2, correct? This operation must be applied on both LHS and RHS. So this will become 1 0 minus 1 by 2, 5 1 0 0 1 3, which is equal to 1 0 0 0 1 0. So this is becoming 1 by 2, right? So this will become 0 0 and 0. A. R1 by 2. So 1 by 2. Next, we made this as 1, right? Make this as 0. This is already 0. So no need of making this as 0. Now make this as 0. How do we do that, students? R2, correct? R2 equals R2 minus 5 times of R1. R2 is how much? 5. Minus 5 of what is R1? 1. So plus 5 minus 5 will be equal to 0. So here we'll write R1 and R3 are unchanged. R1, R3, same on this side. R1, R3. So there is a mistake again here. So this I have written 0, it is actually 1. Same thing. This is actually 1 of A. Correct? R2 by minus 5, R2 minus 5 R1. 5 minus 5, 0. R2, 1 minus 5 times of 0 is 1 only. R2, 0 minus 5 of minus 1 by 2. So that will become minus into minus is plus 5 by 2 it is. Correct? 0 minus 5 of minus 1 by 2 is plus 5 by 2. Next, R2 minus 5 R1. 0 minus 5 times of this, it will become minus 5 by 2. Correct? Okay, 1 minus 5 times of this, so that will be 1 only. And 0 minus, so this will be 0 as well. This and this are matching. Next, this is already 1. So this is already 0. Now we have to make this as 0, right? Only one operation. So here this is in R3. We'll write R3 minus, or R3 equals R3 minus R2. That's it. 1 minus 1, 0. So this will become 0, right? So write R1 and R2 as it is, because we are only doing R3. 1, 0, minus 1 by 2. It is equal to 1 by 2, 0, 0, 0, 1, 5 by 2, minus 5 by 2, 1, 0, and we have here A. R3 minus R2, 0 minus 0, 0. 1 minus 1, 0. This is 0. Now see this, R3 minus R2, 3 minus 5 by 2. Here we'll write, students. 3 minus 5 by 2. So this will become 6 minus 5 by 2, correct? LCM, 3 2s are 6, 6 minus 5 by 2, which is equal to 1 by 2. So here we'll write 1 by 2. Same thing here, R3 minus R2, so 0 minus of minus 5 by 2 is plus 5 by 2. 0 minus 1 is minus 1 and 1 minus 0 is 1 only. Okay, now see, these both columns are done. This column is matching with this and this. Now what you have to do, you have to make this as 1 with respect to this. You have to make these both as 0. So let us make this as 1 now. We can continue on this side only. Okay. We'll take this matrix. We'll make this as 1, right? So here we'll write the operation. Operation what we have to carry here is R3 equals 2R3. 2 times of R3. Correct? So what is this? 1 by 2. 2 and 2 will get cancelled. It will become 1. So R1 and R2 are as it is, right? So we'll start writing it here. 1, 0, minus 1 by 2, 0, 1, 5 by 2, which is equal to 1 by 2, 0, 0, minus 5 by 2, 1, 0. So this will be as it is. Okay, we'll do one thing. 5 by 2 minus 1, 1, 0, 0, 1 by 2. So there is no enough space here, students. We'll carry it on, we'll continue this on here, this side only. Same thing we'll write down. Apply this operation now. R3 equals 2 times of R3. So 0 into 2 is 0, 0 into 2 is 0, 1 by 2 into 2 is 1. 2 times of R3, right? So this will become 5, this will become minus 2 and this will become plus 2 into A. See this, students, this is 0, so this become 1, right? This has become 1 by this elementary operation. With respect to this one, make these both as 0. So how do you make them as 0 now? Here we'll write, so R1 and R2. R1 equals R1 plus 1 by 2 of R3. Correct. What is R1? Minus 1 by 2. Plus 1 by 2 of what is R3? 1. Minus 1 by 2 plus 1 by 2, it will become 0. So this is finished. We have to make this as 0 now. That is R2. R2 equals R2 minus 5 by 2 of R3 plus 5 by 2 minus 5 by 2 of what is R3? 1 plus 5 by 2 minus 5 by 2 cancel. Even this will become 0. We'll be getting our identity matrix here. These operations must be also operated on the right hand side of the matrix. So now which is untouched, students? R1, R2. R3 is, there is no change, there will be no change in R3. So finish writing R3 first. So that will become 0, 0, 1, which is equal to 5 minus 2 and 2 into A. Okay, now we'll use R1. What is R1? 1 plus 1 by 2 of R3, 1 by 2 of 0, 1 plus 0 is 1 only. Same thing. R1 0, R3 also 0, so this will become 0 as well. Now this minus 1 by 2 plus 1 by 2 of 1, so even this will become 0. Same thing applicable here. R1 is 1 by 2 plus 1 by 2 of R3. So 1 by 2 of R3 is 5. Simplify this. So denominators are same, you can add up the numerators. So this will become equal to 1 by 2, 5 by 2 plus 1 by 2, 6 by 2. 6 by 2, correct? 5 plus 1 is 6, 2 1s are 2 3s are. So this will become 3 here. Understanding? So see the rough work on that side. R1 is how much? 1 by 2 plus 1 by 2 of R3 is 5. So 1 by 2 of 1 by 2 plus 5, that is equal to 5 by 2, 6 by 2, which is equal to 3. We have written 3 here. Next, R1 0 plus 1 by 2 of R3. 1 by 2 of what is R3? Minus 2. Plus 2 minus 2 cancel. 0 minus 1 is minus 1 only. Next, R1 0 plus 1 by 2 of R3. 0 plus 1 by 2 of what is R3, students? 2. 2 to cancel, answer is 1. Okay, so this is finished. R1 is finished. Now let's go to R2. R2 minus 5 by 2 of R3. 0 minus 5 by 2 of 0 is 0. Next, R2 minus 5 by 2 of 0 is 1 only. R2, that is 5 by 2 minus 5 by 2 of 1, so that is becoming 0. We got our identity matrix on the left hand side. Complete this row, this will be your A inverse then. You send it on that side, this will be your A inverse. So again, what is R2 here? Minus 5 by 2. Minus 5 by 2. Okay, minus 5 by 2 of what is R3, students? 5. Solve this. So denominators are same again, that is 2. So this is becoming minus 25 minus 5. So that is becoming minus 30 by 2, which is equal to minus 15. So here we'll write minus 15. Understood? Next, R2, that is 1. Minus 5 by 2. What is R3? Minus 2. Plus 2 minus 2 cancel. Minus into minus is plus. So this will become 6, correct? Minus into minus is plus. 1 plus 5 is equal to 6. So write 6 here. Next, last one, R2, 0. Minus 5 by 2. R3 is 1. Sorry, R3 is 2 again. So 2 and 2 cancel. 0 minus 5 is minus 5, right? Minus 5 here. So this is our I, right? Send this A on that side. So that will become A inverse into I equals 3 minus 1, 1 minus 15, 6 minus 5, 5 minus 2 and 2. So this will be our A inverse. Make a note of this. So this is the last problem, students, in the matrices chapter. Okay, so what is very important in matrices is, always remember, make this as 1, these both elements 0. Next, make this as 1, these both elements 0. Next, make this as 1, these both elements 0. You follow this procedure to find out the inverse of the matrix. You'll be easily finding out. Most important thing, also do the rough work. I think this time we have done the rough work and this answer will be right. So previously we did it mentally without any rough work. So there was a small mistake. So I think this is the end of the chapter. We'll be starting with the next class again. Thank you, students.